Okay, this chapter is electromagnetic induction. So it has already been found that current through conductor produces magnetic field. Okay, so by the nature of symmetry, now this nature of symmetry means if current is producing magnetic field, so by the nature of symmetry, magnetic field should also produce current. So this was hypothesized, and this was actually found later by Faraday. He did a series of experiment and verified this result. So let's go through the some experiment and their results. What happened? The first one is a magnet coil experiment. Okay, in magnet coil experiment, um coil was taken and a galvanometer was attached to this coil to find whether there is reading or not, and then a magnet was taken. So initially, if magnet was not moving, okay, if magnet velocity is zero, uh, coil we have this thing we have, let's say, fixed initially. Okay, so then it was found that there is no deflection in galvanometer. Now we started bringing this magnet closer to coil. Now some deflection in galvanometer appeared. Then when we were taking this magnet away from the coil, again some deflection in the galvanometer happened, means some current started passing through the coil. Now if this magnet was brought with a higher velocity, it some further more amount of current started flowing in this coil. The same thing happened when let's say this time we will start moving this coil, but we fix this m- magnet. Means if we start moving it towards the magnet, then some current will start flow. Similarly, when we move the coil away from the magnet, again some current started flow. So uh, it was hypothesized that magnet is producing magnetic field, and due to this magnetic field some current starts flowing. Okay, so basically it is that the relative motion between magnet and coil is responsible for generation of electric current in the coil. Okay, next experiment is coil experiment. Okay, in coil experiment, two different coils were taken. Okay, so in this one we have attached a galvanometer. Here a battery has been attached, so some current will start flowing once this key is connected. So this is your secondary coil, and this one is primary coil. Okay, as you can see here, there is a plug here, plug key. Once you will close the key, so some current will start flowing. So the moment the key was closed, at that very instant, or you can say for a very small amount of time, this galvanometer started showing deflection. Similarly, when this key was opened, then again this galvanometer started showing some deflection. But if this after like just let's say when this key is closed for a very small amount of time, it was showing deflection, but after that time there was no deflection in the galvanometer. Okay, so based on these we will define magnetic flux.